a practice quiz almost. I didn't really intend it to be, but it turned into that. So let's look at the other side. I want to do a couple things. All right, well, let's go over this and I'll ask you a question. So we did Babylonians, and they are Babylonians are base 60. Mayans are basically, no pun intended, base 20. They have that one hiccup because they're trying to incorporate 360. So we know how different base systems work, and to be really honest, what gets me about section 2.3 is it really should be easier than section 2.2. Section 2.2, not only did you have to change bases, but you had to change symbols. You weren't allowed to use a symbol 2. You had to use 2 blueberries or something. You guys know? Section 2.3 is other bases, but we're allowed to use our new ones. Are you catching on? Are you understanding? I'll lay it down. Okay. I like this physical example, and of course I would, because it came up with it. I'm sorry. But you can imagine, as you're reading through this physical example, you can imagine doing something like this. Not just like what we did last time. What we did last time with the little blocks, and you had to reorganize them. If you read through this, so we have a lot of eggs. Just eggs all over the damn place, and we're like, what the hell? So we're going to put them in the cartons. Yes? And if you buy eggs, I'm pretty sure there's 8 eggs in a carton. I only buy eggs when I'm about to bake, so I could be wrong. Or the 12? 12, okay. Sometimes you get half a carton or something. I normally go for that. I don't like eggs. Anybody like eggs? You guys like eggs? I wish I liked eggs, because everything looks neat. I'd love to have an omelet. But eggs are gross. Eggs are food glue is what I say. What's the correct way to use eggs? Keep shit together. Put them in your cakes, your cake stays together. They're food glue. I know. If you like eggs, I'm just a little jealous. It's okay. I just can't. I'm joking. We're going to put them into cartons. And in my cartons, they hold 8 eggs. Just how we are. That's what sets our little company apart. We're the 8 egg company, right? Every crate holds 8 cartons. You guys start to understand the math behind this. Can you imagine a classroom activity that you could actually make something physical? You could have physical cartons in there. And you can have students putting stuff in there. So if I had 9 eggs, for example, how many full cartons and how many leftover eggs? If I fill the carton up, how many leftover eggs? I have 1 full carton with 1 leftover egg. Does everybody see that? Can you imagine the physical activity you could have a student do? That is related to what we did. What we did was just one step removed from real, total physical stuff. It was just little rats. Okay. What if we have 73 eggs? I forgot, I added in crate. Every crate holds 8 cartons. So every carton holds 8 eggs. Every crate holds 8 cartons. With me? So what would a full carton have? How many eggs would a full crate, how many eggs would a full crate hold? 64. Every carton has 8. Every crate has 8. 8 times 8, 64 eggs. So now the 73 is a little bit easier. How many full crates for 73 eggs? How many eggs to fill a crate? 64. So how many full crates? We have 73 eggs. 1 full crate. How many is left? 9. 9. Yes? Is everybody with me? Do you understand how this is the exact same damn work we did for Babylonians, the same work we did for Mayans? Divide, subtract, correct? Because it's trying to do the same thing. What place value system is this? It's not place 10. It's not base 10. It's base freaking 8. Every place means a certain number of 8s. In fact, what we have single eggs. Then we have cartons that hold 8, right? So 1, 8, and then we have a crate that holds 64. So 1, 8, 8 squared. Are you guys really with me? This is a physical example of a different base number system. Some of you guys might have jobs where you have effectively used a different base. You shouldn't look at it mathematically. You're just like, well, yeah, fill that thing up, and I got to start filling something else. I'm like, what's the math? You're doing what's left over. You're dividing. Like, no, I'm not just filling shit. No, you guys. So we do a lot of math every day. We just don't realize it's math. Some math is built in. All right, Jeff, bring it back. What if I go on to say that we plan on putting the crates into trucks, and each truck can hold 8 crates? How many total eggs in a truck if I have a full truck of eggs? Every crate holds how many? 64, and I got 8 of those suckers in the truck. So a full truck of eggs has how many eggs? 512, right? 8 times 64. What idea does that get across in a very kind of silly manner for a student? Every time you make another place, you multiply by this. Same thing with you with base 10. Okay. You gotta get it. This guy's always in my way. Get over here. If we have 500 eggs, what did you just tell me? A full truck has 512. Can we fill a truck with 500 eggs? Can we fill a truck? How many eggs to fill a truck? 512. So if we have 500, can we fill a truck? And a truck is only full if it's got 8 full crates. And a crate is only full if it's got 8 full cartons. And a cart is only full if it's got 8 eggs. Are you guys with me? So can we completely fill a truck with 500 eggs? We're short how many? 12. Okay, so I can't fill a truck. How many crates could I fill? Do it again. How many crates? How do you figure out how many crates you could fill? Well, each crate has how many eggs? 64. 2 crates would be 128. So you're trying to figure out how many 64s. Every group of 64 eggs makes a full crate. With me? And I know crate rhymes with 8, which is neat. Every full crate has 64 eggs, right? So every 64 eggs makes a full crate. So how many full crates can I make? How many 64s are in 500? 7. There can't be 8. 8 times 64 is 512. Too many. Somebody, I really want you guys with me. Somebody with me? Sort of. So we're doing the same math. I'm just trying to force you to look at it at a more physical way. Every group of 64 eggs makes a full crate. So how many groups of 64 are in 500? That's division. That's the one definition of division, right? 500 divided by 64 is 7. So if I have 7 crates, how many eggs have I placed so far? If I have 7 crates, sorry? 448. So how many eggs do I have left to put somewhere? 52. 11. So there's the divide and subtract, right? Division got us 7. Subtraction got us 52. So now how many cartons? Why 6?
Because each carton has 8.
Good. And so if every carton has 8, 6 times 8 is 48. So I have how many spare individual eggs left? 4. So then 4 free eggs. I'm free. Maybe. So that is an example of a real life situation that you could look at as a base value system, a place value system. Right? Okay. So I want to do a few examples with you. I'm going to leave these for you to do. Let's do a few examples together. And I also want to introduce a very strange situation. Let's say I've got 314. So when I write this, that is me telling you that that number, that numeral is in base 5. You guys, that is already in base 5. So it's like I give you a Babylonian number. It's already Babylonian. Wouldn't that involve multiplication and addition? So let me say this again. I've said this already, but let me make it really clear. If I start in somebody else's system and I bring it back to ours, that's always easier. That's always multiplication, addition. If I start in our system and try to go somebody else's, that sucks. That's division, subtraction. So any little subscript means that's the place value system we're in. Why don't we put a 10? Because why wouldn't we? We know if it doesn't have something, we're in base 10, yes. Same way if I write a square root symbol, I know it's a square root, I don't have to put a 2. We just know it is. It's the most commonly used root. So what are the places in base 5? Good, and that's all we need. We only have 1, 2, 3 places, so 3, 1, 4. So it's in base 5, therefore, the places are not blank. It is already in place in base 5. So how do you put this number in Hindu Arabic? Not Hindu Arabic, it's already in, but into base 10. Yeah, how many 25s do we have? 3. And 3/4 is 75 cents plus 1/5 plus a 4. 84. So, if for some reason we had been evolved with one arm, we would have a base 5 number system more than likely. 1, 2, 3, or 5, that's it. Yeah. Let me ask it. Let me start to put something in your head. I think I've said this before, but what's the largest single digit in base 10? 9. Because how do we write 10? Do we have a symbol for 10? No. How do we write 10? How many symbols do we use? 2. 1, 0. Right? So let me ask you kind of a side question here. What if my question would have been, is that a valid numeral? Is that valid? So what's the highest single digit in base 10? 9. If you have 7 eggs, can you fill a carton? No. I have 8 eggs, can I fill a carton? So then I have 1 carton, no eggs. So base 8, how do you say 8? 1, 0. Base 10, how do you say 10? 1, 0. Base 5, how do you say 5? 1, 0. So is there a single digit 5 in base 5? No. So really hone in on this. Base 10, the largest single digit is 9. Why do we not have a single digit for 10? Because when I get to 10, I'm in the tens place. I have 1 of them and no 1s. So how do I write 5 in base 5? Right, let me start with this. How do I write 4 in base 5? Like that. Ooh. That's fine. 4 in base 5 is 4. How do I write 5 in base 5? What are the places in base 5? 1's always 1's. 5. So if I have 5, how many 5's do I have? Holy shit, and how many 1's do I have left over? None. So that is how I write 5 in base 5 is 1, 0. On one level, that shouldn't surprise us. What you guys need to do, and this is going to be really hard for you, and I was talking to a student earlier in office hours, you grew up in base 10. It is more fundamental than freaking feet and inches, because you didn't learn that until way later. You started 1, 2, 3, 4, 5, 6, 7, 8, 10. I'm trying to, you're like, let me just say all the numbers and make mom happy. Good job, good job. Are you guys coming with me? So a lot of what we're doing here forces you outside of that, which you have never even thought you could step outside of that. Yes? You should really be with me, because this is so freaking cool. As a teacher, you make decisions how to run your class. As a human species, we made decisions as to how to run everything. We had to make a decision. It wasn't really a decision as so much as, well, what just makes sense? 1, 2, 3, there you go. So then if I have a full set of fingers, I call that 1, 0, and then I kept going. Yes? So this would not make any sense. The same way, how do I write 510? Is this a good way to write 510? That makes no sense. I can't represent 10 with a single digit. Not in base 10 anyway, we'll get there. Okay. So can you guys tell me, what if I had base 3? Base 3. Can anybody give me some digits that work in base 3? Give me a digit that works in base 3. 2? Yes. Somebody else give me another one. Any digit that works in base 3? 1. Sweet. Give me one more. 2 again. Okay. And what else works in base 3? Does 3 work in base 3? No. No. Let me say this a different way. Is there a way to represent 10 with a single digit in base 10? So is there a way to represent 3 with a single digit in base 3? No. Disconnect 10 being some amazing thing. It was just a choice we made. Why is 10 so amazing to us? Whenever you get a round number, don't you, when you really didn't need to, don't you kind of go, whoa, that's weird, right? If you count how many stones are in your yard, you're like, there's exactly 30. That's, ooh, what's that mean? But 10 is just bullshit. 10 is just, we just picked it. It doesn't mean shit. I don't know if you guys are with me or not. We put a lot of emphasis on 10, because of course we did. It was instrumental in our evolution. Holy shit. Okay. Whatever's true about base 10 is generally true about every base. So base 3, what's the highest single digit? 2, 1 less than the base. Because the minute I hit the base, it's sort of like an odometer in your car. Even if you don't drive, you know, odometers. So when I get to 9, what happens next? This one goes back to 0, and this one flips over 1. Yes? So when I go 0, 1, 2, so base 3 would go 0, 1, 2. Then I flip over 1. I really want this understood, because what place, this is the 1's place, this is the 1's place, this is the 1's place, this is the 3's place, yeah? So once you got 0, 1, 2, now the next thing I've got is 1 whole 3 and no extra 1s, yes? So doing, how would you write 4 in base 3? Not even doing like math, just how would you write 4 in base 3? You can do it. How to write 3 in base 3? 10. How to write 4 in base 3? 11. Yes? Isn't that just adding 1? All right, let me see if you guys are really with me. And you're all like, dude, you lost me at, welcome back from the long weekend. So 0 is 0, 1 is 1, 2 is 2, that's all amazing. This is 3. So 11 would be 4, because what am I doing each side? I'm just adding 1, yes? But I have to add 1 in a way that fits in the base system I'm using, right? So the place value system I'm using. So if I add 1 to 10, I get 11. Ooh, we've learned so much today. But that's how it works. I have 1, 3, and 0, 1s. If I add 1 more, I have 1 more 1. So of course I've got 11. Well, what does that really mean, 11 base 3? Means 4. Put a little base 3 down here. I'm really overloading this with a lot of information. Okay. So then how do you write 5? Holy shit. How do you write 6? No. Why does that not work? That's the same way as somebody saying 19, 10 to 10 or something. I don't know. Like 29, 2010, 2011, 20. You with me? Really? Do you see how they didn't roll it over the right time? Base 10, when do you roll it over? Every 10. Base 3, when do you roll it? Every 3. So do you see how 3 is 1, 0? 6 is going to roll over, so what's it going to be now? If I add 1 to 2, it's 3, but how do I write 3? Let me see if you guys are cool with this. And you're all like, we're not cool with any of this shit. So if I have 12 base 3 and I try to add 1 to it, 2 plus 1 is 3, but how do I write 3 in base 10? 10. So do you see how that would carry? Now listen, we're not going to do straight arithmetic in other bases. Don't freak out. But I wanted to show you that one example. You all know you carry the dumb 1. But when do you carry the dumb 1? when you hit the base, because that's when the next thing should roll over, just like an odometer, yes? So it doesn't matter what base I'm in for that rule to work. No, we just happen to be a base 10. So we think it's all about 10. No, it's all, oh God, Jeff, really? Oh, I apologize for what I'm about to say. It's all about the base. It's not about 10, it's about the base. Didn't mean that to happen. Sorry. Okay. No treble, okay? Sure. Is that song really old now? I think it's really old now. So that number we just made, leaving this aside for the moment, that number we just made, how do you convert it back to base 10? What do you identify? Is it in base 3? Yes, because you can see it right there. It's in base 3. So what place is this? Ones, threes, nines. Kick ass, right? How do you find the next place? The same way you do in base 10. Just keep multiplying by the base. You guys look at, what do we have in base 10? Ones times 10. Tens times 10. Hundreds times 10. Thousand, and just keep going. So you're going the same. How about the other way? You divide by 10. That's where we get decimals. That's where we get tenths and hundredths, and you sound like you have a lisp. So how do I build base 3? 1 times 3 is 3 times 3 is 9 times 3 is 27. Blah, 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 blah. But I only have 3 places. I can stop there. You guys with me? So how do I piece that back together into a base 10 number? Yeah, I have how many nines? 2 nines plus 1 3 plus 2 ones, and that would be 23. And again, I don't think anybody got this reference, but Jim Carrey with Freetown. Okay. Anybody ever seen the movie 20, the number 23? Okay, you're fine. Don't worry about it. Is that somebody trying to get in here? No. Okay. How are we doing so far? I need you to notice something. This is very, very trippy on one level, because it's messing with base 10. It's not only messing with it, it's just opening your eyes to the fact that base 10 was a choice we made. It was a choice that was kind of made for us, just because of evolution. But it could have been base 3, it could have been base 2, it could have been base 12, right? So on one level, this is trippy, because it's kind of like all of a sudden trying to do metric when you've never really used metric. It's the same idea. On the other level, the math is the math part. Is the math hard? That's required. The math is easy as shit. But it almost doesn't matter if the concept doesn't make sense. Okay. So accept that the math is easy. It's not the math that's the problem. It's the concept that's the problem. Right? Multiply, add, that kicks ass. Especially if I'm allowed to use a calculator, Jeff. Now, let's do, I think you guys get the idea. If it starts off in a different base, you guys have, this is probably one of the better known different bases, is base 2. Because what's base 2 used for? What's base 2 used for? I see what you mean, but computers, right? Have you ever heard of binary? Yes. So, very quickly, this is not part of the class, but for computers, 1 means the voltage is on, and 0 means the voltage is on. It's literally that. So all this electricity, and it just puts, as a little gate, and it says, put electricity if it's supposed to be 1, don't put it if it's supposed to be 0, and that's how it communicates with itself. And that's how we communicate with it. Isn't that crazy? And then the actual shit we do is just built on all these layers so that we don't have to know that directly. Yes? All right, I'm sorry. That's it for computers. Base 2. How many places are in that number? 7 places, yes? But it's only base 2. So even though that to us looks like 1,011,011, yes? Base 2 is going to be much smaller when I convert it to base 10. You guys follow? Because every place is now much smaller than base 10. What is every place? You write it bigger. What are the places? I always start with 1s, 2s, 4s, 8s, 16s, 32, 64, Right? You guys with me? I don't care what base I give you. How do you build the places? Keep multiplying, start with 1, and just keep multiplying by the base. And then how do you put this back together? This kicks a lot of ass, because what's the biggest single number in base 2? What's the biggest single digit in base 10? 9. Biggest single digit in base 3? 2. Biggest single digit in base 2? 1. If you think about it, that makes the math stupid easy. It's never really multiplication, it's always addition, right? Add 164 to 116 to 18 to 12 to 1. Yes, you guys kind of see that? So what do you get there? Yes, it's negative. So that number to a computer would mean 91. And just to really bring it back for a second, how would we put this number together? What base is this in? Why is it not a mean question for me to ask? Did I say it was in a base? No, so what base do we know it's in? Tens. So what place is this? Ones, tens, hundreds, thousands. So what is this? This is 1,000 plus 400s. I mean, this is the same stuff that's behind the scenes. But why do we not actually have to do the math of it? Because we grew up in the damn thing. We know what 1427 means. We don't have to translate it to anything else because it's already the language, the mathwich? I don't know. It's already the language of numbers we speak. So when I have a different base, it's translation. I got to translate it back into our base. But the math you do, same shit. Same math. All right. So, what about going the other way then, Jeff? What if I had 4,981 and I want to convert that to base 9? So, is it already in base 9? So if I write the places for base 9 down, are the places filled or are they blank? It's not in base 9 yet, right? So do we know what the base 9 numbers are? No, so the places will be blank. Right? I'm just trying to show you. If you remember, if we start with ours, it should be worse. It should be division subtraction, which means the places are blank, and that's why it's worse. So what's base 9? What are the places? Ones, nines, 81s, 729. Now watch this, watch real quick. What's 9 times 700? What's 9 times 7? 63. So what's 9 times 700? 6,300. So this is something bigger than 6,300. Do you see why I don't give a shit what the actual number is? I mean, you can put it in your calculator and find out. Who cares? Is that too much? By the way, you see how it's greater than? Sorry, that's greater than. Do you guys follow? So just put it in your calculator, see what the number actually is. Does it really matter? No, once it's too big, you're not going to use that place. Right? I can't. So how do I figure out what goes into 729's place? Yeah, divide. How many 729s? How many groups of 729 are in 4,981? They divide. That's like the definition of division. So, like if I asked you, I got 87 people, I want to make teams of 5. How many teams can I make? You would divide. That's all I'm asking. I want teams of 729. I got 4,981 people. How many teams can I make? You divide. And this, if you realize, it's the same shit we did with Babylonians, same shit we did with Mayans. Those are worse though, because I then also had to translate into their numerals. Pancakes and blueberries and shit. So what is it? 729 goes into 4981. How many times? 6 sounds right. And that'll be what, Jeff? You can, come on, math boy. I don't know, 4,354? No, 4,000, I'm off. What is it supposed to be? 4,374? That was close. If you subtract those, you get 607. I believe I can do it. Alright, 607. Is that right? Is everybody with me? This is the same math we did with Babylonians and Mayans. The kick-ass thing is, once I get those places done, I'm done. I don't have to translate to inequality symbols and chisel marks. Okay. So I got 607 left to take care of. So one way I was trying to describe to a student is I got this much work to do. If I do this or this, I got that much work I did. I got this much work left to do. So how many 81s help me? 6? 7? 7 sounds right. So if I do 7 81s, that's how much?
567, sorry.
That's all right. And then how much work do I have left to do? 40. Here's a real quick, guys. A little side note. We're going to do this later this semester, but I want to throw this at you. What does subtraction do? If I subtract two numbers, it tells me how. Let me see. If I was on the 10 mark, on this big ruler, and somebody else is at the 17 mark. 17 minus 10 tells me how far apart we are, yes? Are you guys with me? So subtraction, stay with me. Subtraction tells you how far apart two numbers are. If I move one of the numbers down 7, and I move the other number down 7, are they still the same distance apart? Do you understand? Subtraction tries to get the distance that two numbers are apart. If I move both numbers by the same amount, they're still the same distance apart. So watch this. And I know you all have calculators, and I don't give a shit. If I move this down by 7, and I move this down by 7, what's 600 minus 560? 40. Much easier problem, yes? Much easier problem, yes? All right, sorry, I'll stop. So then I need, so that's what I have left. So I need how many 9s now to take care of some of this? Yeah, 4 9s, and then of course I got 4 1s left. You with me? Can anyone identify what number could I have gotten somewhere that would have told me I made a mistake? Huh? A number larger than 8. Kick ass. Because can 9 exist in base 9? And if you think it's a weird question, you're like, how can 9 not exist in base 10 doesn't exist in base 10. It doesn't. There's no single symbol that means 10. 10 is made of 1 and 0. There is no 10. There is no 10. Sorry, there is no 10. You guys at all? Does that make sense? I need to. So if you would have, can you imagine somebody mistakenly putting a 5 there? When they subtract, wouldn't they have gotten a much larger number than 7? They would have gotten something bigger than 9, and that would have told them, hey, you made a mistake. I guess. So the same math, exactly the same math, except we're done. I don't have to translate into any symbols. This is 67.44. So if our entire species had developed with a base 9 number system, like one of our hands didn't have a pinky for some reason, so we have base 9, yes? When you saw 6744, you would know that meant 4,981 things. When you see 4981, do you guys understand what it means? Yes, that means 4,981 somethings. Yes? If we had base 9 and we saw 6744, it would mean the same thing 4981 means to us now. We wouldn't even stop and think there was a problem. You would be freaked out if I said base 10. You're like, what the hell are you talking about, you weird ass math person? So let me continue. Let's talk about base 12. Why would base 12 be weird? Why would we subsect? Jeff, why would we suspect? Lord, what am I drinking? Do it again.
Our base is 10, so it's less than 12, so it doesn't mean
So what's the largest single digit symbol we need for base 10? I need symbols up to 9 in base 10. In base 10, I need a symbol for 0, 1, 2, up to 9. Is everybody with me? The minute I got those, they make everything else. How do I make 10? 1, 1, 1, 0. Yes. Base 12. What's the largest single digit that we need one symbol for? 11. Now to me, this is normally the trickiest part. And this is the one that really pushes us to realize everything that's true in base 10 will be true everywhere else. So if the largest thing, so if we wanted a base 10 number system and nothing existed yet, we would have to have a symbol for 0, a symbol for, so we would make those symbols, yes? And then we go, everybody agree? And the one guy that doesn't agree, we would kick him out, throw him in the volcano or something, and then we continue with our civilization, yes? If we had a base 12 system, we would have to come up with a single symbol for 0, 1, 2, like we do, up to 9, but also 10 and 11. You guys who? So, I want to focus on this one because the book does something really dumb, but it'll be okay. So base 12. We have 0, 1, 2, 9, but then 10 needs to become, so this is base 10, this is base 12. 10 needs to be a single symbol. The book stupidly calls 10 T. Now, on one level, you're like, what's wrong with calling 10 T? You're a weird ass math boy. Because there's another base that is actually used very often, and it's base 16. Base 16 is how we identify colors in computer programs. Nobody does HTML anymore, but that's okay. But has anybody ever designed a web page in any of your classes? Did you ever have to do anything with a web page? No? Okay. I'll try to look up some examples for you here in a bit. So here's the symbol we should use for 10. A. We just decided, somewhere in time, we decided that using base 12, base 16, whatever, is useful. It can contain more information more compactly. What is the big thing about computers? What do you run out of? Storage space. So what did we do? If I use a bigger base, I can represent bigger things with less stuff. Yes? Which means more space overall. I guess that all with it. So just like the weird, if you really think about it, the symbol for 2 is weird as shit. You just go, oh, it's a C. No, it ain't. I mean, what? You guys don't, and some of us do this with a straight line, if you're really weird. Anybody do that? Sorry, you know, I just said you're weird, but you don't want to not be weird. You guys are all with me? If you really think about the symbols, look at 3. I mean, what the shit's that? It's almost an 8, but it just sort of gave up. No? I don't know if you can, you guys. I have no idea how you look at me. You're like, oh, I go to class and he talks about the number 3, like it's weird. It is weird. So, we cannot use this because, real quick, in base 12, what would this mean? What would this mean in base 12? What are the places? Yeah. I heard you, you're right. This is the ones place, this is the, so 10 means 12, yes? 10 base 12 means 12. So 11, if 12 is 10 in base 12, 11 has to be its own symbol, right? It has to be a single digit. So we use A to mean 10, and we use, you're not going to believe it, B to mean 11. Let me see if I can, you can do it, Jeff. I have faith in you. Let's see, can you do it? I did it. Okay. Let's try to make 23, just to continue this. It's kind of funny, this works. Try to take 23 and turn it into base 12. You guys will help me, and I'll show you exactly why we need a symbol for 10 and a symbol for 11. So it's 23 is our base, yes? So when I set the bases for base 12, they're blank. Yes, I don't know what base 12 is, so blank, which means it's gonna be harder. It's gonna be division and subtraction. What are the places in base 12? 1 and 12 and 144, good. Just trying to get you used to going too far, but yeah, I mean, 12 is almost 23, so you know. So how many 12s do I need to make 23? 1. And how many leftovers are there? 11. Yeah, we get it, Jeff. If I write 111, what does that mean in base 12? Or what does that mean in base 10, actually? Sorry, we're changing this. Oh, I am changing base. What would this mean in base 12? 1, 1, 112, 1, 144. Is that 23? I need you to see the problem. How do I put that? I need that in one place. But we're using our rules. We're not in Babylonian. I can't shove a bunch of shit into one place. We know it's got to be one digit, yes? Do you understand now? I need a digit that means 11, so I can put one symbol. Do you agree I need 11 ones? There's no way around that shit. I got 112. I need 11 frickin' ones. But if I try to write 111, that's got 3 places now. It's supposed to have 2 places, yes? Do you start to see? We need a single digit for 11, a single symbol. And we chose that symbol to be B. So how do I write this then? 1, you can do it. B, base 12. That means 112 and 11 ones. Just like if you're playing poker, what does a jack mean? Anybody? If you're playing cards, what's a jack represent? 11. Single symbol means 11. Yes? So we've already got exposure to this idea. Now, if you never play cards, I'm sorry, that was a bad example. How are you guys feeling right now? Does that make some kind of sense as to why there's suddenly letters in our number system? We could have created brand new symbols, but they just, back in time, they chose not to. They chose to use letters. So let me give you, can you convert, let me throw this at you out of nowhere. Can you convert, Jeff, just make something. Can you convert CAB, base 14, to base 10? So am I at a base higher than 10? Yes, which means I need to include, and obviously if A is 10 and B is 11, what's C? 40 shit. And of course in base 14, what's the highest single digit? 13, so I would be A10, B11, C12, G13, yes? That's what I would need for base 14, you're with me? I don't have any DDs, that's fine. That kind of looks like my report card from college and grad school, when I was working 3 jobs. Can I tell you about that when my report cards have personality? They weren't like, they were, because I was working 3 jobs, I know. Anyway, sorry. I am currently in base 14, yes. So do we know what each place is? And actually, let's do this first. What's C? In our number system, what does C represent? 12. What's A? 10. And what's B is 11. What place is this in? 1's place. 14's. I didn't like that. 196. Okay. Do you this is a little bit more like Mayans and Babylonians. We have symbols that we have to translate into our system, but it's still nowhere near as bad. It's still letters. We're used to those. How do you piece this number back together? How many 196s does it have? 12. How many 14s? 10 14s. And how many 1s? 11. Same math, yes? Same math as any base. $23.52, $24.92, 2503. I'm okay if I'm wrong. 352. 2492. I'm pretty sure it's 2503. Is that right? Yeah? Okay. Nobody was saying anything, so I'm like, shit. If I try that in my head and I get it wrong, it's fine. Just say what you got in your calculator. I just gotta challenge myself. It's my one skill, so I have, to show up. How you guys feel about this? So can you imagine base 37? What would happen in base 37? We would need digits up to 36. We have 0 through 9, and then A starts at 10. You with me? I don't want to try to push this too much, but again, how many letters do we have in our alphabet? So that would be the end of our letters, yes? We'd use A through Z. Are you with me? So then what do we do if I have base 71 then? We start making different symbols. How often does base 71 happen? Not very often. Do you guys know the number pi, by the way? Everybody knows pi, right? It comes from circles. You could have base pi. That's all I'll say, I'm sorry. Okay, so what I want you guys to do, take that handout we were working on, and do the problems. Down here. If you want to work with people near you, feel free. You don't have to get back into your same groups unless you really, really, really love your group. You can get back together, I guess. It's up to you. Let me do a couple of these and we'll finish this up next time then. Real quick, by the way, guys. My original plan was to go a little further, get into chapter 1. It's my fault we didn't. Anybody understand my shirt?
No, I was trying to look at the whole class, I didn't understand it.
You understand the phrase, right? I literally can't even. Yes? How do you write an even number? What's true about an even number? Every even number, what can you do to it? So, can you write an even number as 2 times n? 2 times 1, 2 times 2, aren't those all even? Because they all have a factor of 2. So how would you write an odd number? Isn't every odd number 1 less than an even number? 2n minus 1 is what kind of number? Odd, so I literally can't even, okay. Very math jokey, I know. Look, guys, real quick. Everybody confuses this, and I don't blame you, because this is very weird. This is already basic. Let me ask you this real quick. 4, 2, 5, 1. This is base 10, because there's no base put on it. So what place is this in? 1. What place is this in? 10. I have to know what base it's in, so I know the value of each place, yes? If I know it is in base 8, then what place is the 1 in? 1. What place is the 3 in? 8. What place is the 2 in? 64. And then I just have 2 64s plus 3 8s, yes? So when you go from a different base to us, it should be multiplying at. When you go from us to something else, it should be dividing, subtracting. So next time we're going to get into, we're going to finish this, first thing. Sorry. The quiz is graded, and then we'll get into chapter 1, which is everybody's favorite word problem kind of stuff. Yay.
Thank you.
Man, that time flew. Oh yeah, don't forget your IDs and phones and stuff. Please, dear God. Thank you.